Hi Year 12s, 22D, non-linear graphs. I'll give you a chance to copy down the notes. Remember to pause it when you need to. Alright, good job guys. Okay, so pretty much this is exploring different types of graphs. So here's our generic formula, y equals k, x to the power of n. Now k is a constant, it can be any value, which we can work out in a few minutes. And n, the number of that depends on whatever type of graph it is. So I'll explain what I mean. A straight line graph, n is equal to 1. So if you've got y equals kx to the power of 1, it's just the same as x by itself, like anything to the power of 1 is itself. So straight line graphs have the form of y equals kx. So k is a constant, so an example is y equals 2x or y equals 5x. And as we know with straight line graphs, 2 is the gradient there, in this case 5 is the gradient. And then remember the formula y equals mx plus c, so if there's 2x plus 3, that's the y-intercept, would be 3. But anyway, so I've just drawn some examples here. So this graph here is y equals a half x, because the gradient is a half, so it's a flat line. The rise is 1 and the run is 2. And this one's a steeper gradient, it's y equals 2x. So that's pretty much all we have to do for straight line graphs. The value of n is 1. So let's move on to the next type of graph, parabolas. Now parabolas are curvy graphs. They don't have any straight lines in that actual graph. So parabolas, the value of n is equal to 2. So example is y equals k, the constant again, x squared. So anything with x squared in it is a parabola. So again, that's what a generic parabola looks like. It could be wider, it could be skinnier, or it could be upside down if it's a negative one. But we need to find out that value of k. So I've written a few notes here. The value of k determines how wide or thin the graph is. And the way we find the value of k, if we know one point on that graph somewhere, we know an x value and a y value, so we can substitute that value in to find k. So an example, if we know the point 225, we know this is our x value and that's our y value. Remember the x and y coordinates? So into our generic formula, y equals kx squared, we substitute y is 25 and x is 2. So we substitute that in, we get 25 equals k times 2 squared, which is 4. Divide by 4 and we get k equals 6.25, which is 6 1/4 or 25 over 4. Either, all of those are fine. And then we can write down our actual equation. So y is 6.25 x squared. So this means that it's a little bit of a skinnier graph. And that's what you do, you use this same process, substitute a known value into the generic equation and you can find the value of k. So it doesn't matter whether it's a cubic or a parabola or a straight line graph, if you've got a known point, you substitute it in. Excellent. Let's go over here briefly, look at some other graphs. Hyperbolas. The value of n is -1. So if we look at our generic formula again, y equals k x to the power of -1, using index laws, to make that a positive power, you bring it down to the bottom of the line, so the numerator and the denominator, so it goes down to the bottom. So the generic formula is y equals k over x. And that's what the graph looks like over there. These aren't too common in further maths. It's good to know what they look like. And these are examples of parabolas, 1 over x or y equals 5 over x. If you're not sure what the graph looks like, use CAS. You type whatever the equation is into CAS and you graph it and then you'll know what the graph looks like. And the next one, it's a bit more common, is cubics. The value of n is 3. So y equals kx cubed. An example is y equals 3x cubed, or it could be 5x cubed, or -2x cubed. And this is what a cubic might look like, or it could be around the other way, it could be skinnier. But generally speaking, that's what the shape of a cubic. And I've set a few notes down the bottom. So again, if you need to know the shape of any type of graph, chuck it into CAS and it'll show you the graph. That's what it's there for. And the last thing is, if you see this, if it says sketch the graph or do a table of values, that means you want to find all the x and y coordinates between, and it says this here, it means the value of x goes from -3 all the way up to 3. So for a table of values, if it said do a table of values of that, So you'd have x and y, and you'd have -3, -2, -1, 0, 1, 2 and 3. And then you'd have to substitute each value in to find the y value, or use CAS and scroll over along the graph and fill in the values there. So that means, and this means is equal to as well, and it's equal to, so x goes from -3, including -3, all the way up to 3, including 3. So all you have to do in this exercise is do a couple of table of values like that, fill in the values, and also there's a couple of examples where you have to substitute a known point in and find the equation. So have a go at that, guys, and I'll see you soon. Bye.